Okay, Wildcat, so we're at 6. I want to believe imaginary and complex numbers. The student works 1, 2, 3, and 4. All right, let's take a look at the next page. All right, the teacher works 1A and 1C, and the student works 1B. All right, number 1. The 0 is this point right here, which is x equals 5. Now, the x-intercept is the same point, which is 5, 0. So the 0 and the x-intercept are the same thing. Okay? Now, the y-intercept occurs somewhere up here. So we're going to need to go to Desmos to see where that occurs. Okay, so let's go ahead and grab this in Desmos. So x squared minus 10x plus 25. Okay, and then we're going to zoom out. Keep zooming. There we go. So our y-intercept is 0, 25. Okay, so somewhere our y-intercept occurs somewhere up there. Okay. Okay, and then axis of symmetry is the line that cuts the graph in half. So that occurs at x equals 5. Okay, the vertex is this point right here, which is 5, 0. All right, go ahead and finish up A. All right, let's take a look at C. Okay, so this doesn't cross the x-axis, so there are no zeros. And it doesn't cross the x-axis, so there's no x-intercepts. Okay? The y-intercept is this point right here, which is 0, 1. The axis of symmetry is what cuts the graph in half. So in this case, it's x equals 0. All right, and then the vertex is this point right here, which is 0, 1. All right, go ahead and finish up 1A and 1C and work 1B. All right, let's take a look at the next page. All right, activity 6.1, the number I. Consider the function p of x equals x squared plus 1 and its graph from the getting started. Okay, determine the zeros of the function. So to do that, we set the equation equal to 0 and solve for x. So we're going to subtract 1 from both sides. We get x squared equals -1. And then we take the square root of both sides. Remember, square roots plus or minus. The square root cancels the squared. So x equals plus or minus the square root of -1. Which can be rewritten as x equals the square root of -1, which equals 1i, or x equals negative square root of -1, which equals -1i. All right, go ahead and finish that up. All right, let's take a look at 2. Consider the solution. Does the solution fall within the real number system? Explain the reasoning. No, the square root of a negative number is an imaginary number. All right, go ahead and finish that up. Let's take a look at the next page. In order to calculate the square of any real number, there must be some way to calculate the square root of a negative number. That is, there must be a number such that when it's squared, it is equal to the negative number. For this reason, a mathematician finds what is called the number I. The number I is a number such that I squared equals negative 1. The number I is also called an imaginary identity. So it says, if I squared equals negative 1, then what is the value of I? So we're going to solve for I. So we're going to take the square root of both sides. The square root cancels the squared, so I equals the square root of negative 1. Okay, let's take a look at number 4. Recall the function p of x equals x squared plus 1. Write the zeros of the function in terms of I. Okay, so to do that, we're going to solve for x. So we said x squared plus 1 equal to 0, so we subtract 1 from both sides. We get x squared equals negative 1. Take the square root of both sides. Remember, the square root is plus or minus. So the square root cancels the squared to get x equals plus or minus the square root of negative 1. So x equals the square root of negative 1, which equals 1i, and x equals negative square root of negative 1, which equals negative 1i. So the zeros of the function are x equals 1i and x equals negative 1i. All right, let's take a look at number 5. How can you tell if the graph of a quadratic equation, whether or not it has real solution or imaginary solution? If the graph of the quadratic equation intersects the x-axis, the equation has real solutions. If the graph of the quadratic equation does not intersect the x-axis, the equation has imaginary solutions. Okay, let's take a look at the next page. Activity 6.2, the complex number system. The set of complex numbers is the set of all numbers written in the form of a plus bi, where a and b are real numbers. The term a is called the real part of a complex number, and the term bi is called the imaginary part of the complex number. The set of complex numbers is represented by the notation C. The set of imaginary numbers is the set of all numbers written in the form a plus bi, where a and b are real numbers and b is not equal to 0. The set of imaginary numbers is represented by the notation. A pure imaginary number is a number of the form a plus bi, where a is equal to 0 and b is not equal to 0. Okay, go ahead and look over the rest of this page. Kind of study that chart, and let's take a look at the next page. A complete each statement with always, sometimes, or never. A. If a number is an imaginary number, then it is always a complex number. B. If the number is a complex number, then it's sometimes an imaginary number. If a complex number is a real number, then it's always a complex number. D. If a number is a real number, then it's never an imaginary number. E. If a number is a complex number, then it's sometimes a real number. 2. Use a diagram on the previous page to list all number sets that describe each number. Okay? And we're going to write A in orange. Okay? 3 is a natural number, a whole number, an integer, a rational number, a real number, and a complex number. Okay? So we come to the chart. So 3 is a natural number. It's a whole number. It's an integer. It's a rational number. It's a real number. and it's also a complex number. Okay? All right, let's take a look at the next number. B, the square root of 7 is an irrational number, a real number, and a complex number. Okay, and let's go and do that in purple. Okay? So, the square root of 7 is an irrational number, it's a real number, and it's also a complex number. All right. Let's take a look at the next number. All right. Let's do this in red. So 3i is an imaginary number and a complex number. Okay. So 3i is an imaginary number, and it's also a complex number. Okay. Let's take a look at the next one. Okay. 5.45 repeating is a rational number, a real number, and a complex number. Okay. So it's a rational number. So 5.45 repeating, it's a rational number. It's a real number. And it's also a complex number. Okay? Alright, let's take a look at the next number. Alright, 7/8, let's do in blue. 7/8 is a rational number, a real number, and a complex number. Okay? So it's a rational number, it's a real number, and it's also a complex number. Okay? Alright, and then let's take a look at the last number. Six minus I is an imaginary number and a complex number. Okay, so let's come over here. So it's an imaginary number, so 6 minus I, and it's also a complex number. All right. So give me a minute to make sure you have those written down. All right. Let's go to the next page. All right. You can look over and read over the worked examples if you like. The teacher works 3B and 3D, and the student works 3A and 3C. Okay, so B. The square root of a negative number is imaginary, so that can be rewritten as I square roots of 12. But that can be simple. The 12 can be simplified. We can rewrite this as I square roots of 4 times 3. 4 times 3 gives us 12. Okay? And why we do that is because now we can say we have I times the square root of 4 times the square root of 3. Well, the square root of 4 is 2, so this simplifies to be 2I square roots of 3. All right, go ahead and finish up B. Let's take a look at D. Okay, so we can rewrite this as 6 divided by 2 minus, we can put a 1 here, 1 divided by 2. Now, the square root of negative number is imaginary, so that's 1i square roots of 8. Okay, now 6 divided by 2 is 3, minus, we're going to leave the 1/2 I there for the moment. The square root of 8 can be rewritten as the square root of 4 times 2. Okay, and the reason we do that is because now we can rewrite this as 3 minus 1/2 the square root of 4 times the square root of 2. So then that's 3 minus 1/2 I times 2 square roots of 2, which we can continue simplifying. That's 3 minus 2i divided by 2 times the square root of 2. Well, 2 divided by 2 becomes 1, so you're left with 3 minus I square roots of 2. Technically, you can put a 1 there if you want, 1i. Okay, go ahead and finish that up and work A and C on your own. And have a wonderful Wildcat day.